panel, we'll be talking to some people who might help put in place that necessary additional grid infrastructure. I'd like to welcome Jeppe Johansen and Maxime Toulotte here on stage. RTE, French grid operator RTE, was going to participate in the panel, but they cancelled their participation for political reasons, with the election looming this Sunday, obviously. Welcome. Good morning. Jeppe, you are Chief Advisor at the Danish Energy Agency. Welcome.
Thank you.
Denmark has so far 2.6 gigawatts of offshore wind energy that's up and running in its waters, but there's much more in the cards, right?
That is correct. Yeah, and thank you very much for being here. It's a pleasure. As it might be well known now, there has just been a tender in Denmark with an additional 6 gigawatts being tendered out in April this year. And we obviously look very much forward to that amount of capacity. I have to mention that on top of the 6 gigawatt, there is an uncapped overplanting possibility. So with a realistic, maybe even 4 additional gigawatts on top of that. So a lot of capacity is planned for Denmark in the coming years.
And not all of it is for domestic consumption, right?
No, that's correct. First of all, the 6 gigawatt, then there is a guaranteed grid connection to that, to the Danish grid system. The top one for overplanting, the developers can do that, can use that for whatever purpose they need. Last year, we had an electricity consumption in Denmark covered by renewable energy of 63%, based on the renewables that we have already. So obviously, when we install this, we will have a large excess capacity in Denmark. So yes, a lot of it will be exported, both as power, but also we have an ambitious target of using that excess power to produce hydrogen and export that also.
To export some of that power, you obviously need interconnectors. Denmark already has a number of interconnectors. You're also working on energy islands. That turns out not to be that easy, right?
That is correct. Yes, in order to utilize all that vast amount of wind power, we obviously need interconnectors. Denmark is already connected to all our neighboring countries. We have interconnectors to Norway, Sweden, Germany, UK. There is the Netherlands. There are plans also to other countries. Yes, so the interconnection part is obviously very important. Currently, it's point-to-point connections. And I mean, these are being used very much in order to even out the demand and of electricity throughout Europe. So that's very good. And for the energy islands, yes, there are several reasons why energy islands is a very good idea. We have made this Ostend declaration together with 8 other European countries, saying that in the far future, 2050, we should actually utilize up to 300 gigawatts of offshore wind in the North Sea. And in order to take that power and distribute it to our neighboring countries and to the rest of Europe, it is very important to have these hubs or islands where you connect or collect the wind power and then transmit it through interconnectors to other countries, yes.
But you were part of the team developing the North Sea Energy Island, right? You told me it was actually not that easy. The team was dissolved at one point, or
yes,
what happened?
That's correct. I mean, in the Danish Climate Act, it was decided that we should have, one more island to the number of islands we have in Denmark. Our minister at that time, he was very proud, saying that we will become one island richer, an artificial island. So the Danish Energy Agency was asked to make that happen. So we were actually starting up a department making the tender conditions for constructing that island. It turned out to be a little complex. A huge island should collect up to 10 gigawatt of offshore wind. There you need a lot of electrical equipment on top of that. The electrical equipment used for collecting this, distributing out to other countries is immature. It demands these new HVDC breaker systems, multi-terminals, connecting the interconnectors to different countries. That has turned out to be very, very complex and also very expensive. So it was then decided to close down our department last summer, but the work is still going on. We are looking into an alternative solution without an artificial island, but just using platforms to have all the equipment on platforms connected with cables.
Right, so we should be watching this space.
Yes. Yeah.
Thank you very much, Johansen. Oh,
a final comment here.
Okay,
Yes.
go ahead.
So I just want to say that there is definitely a huge need to collaborate and to introduce all these new technologies. And it's only to say that the politicians and the policymakers out there, they really have to be bold. Yes, it does cost a lot of money. There is a lot of immaturity in the technology. But it's very important that it's being taken, because everybody's asking how much does it actually cost, but nobody's asking how much does it cost if we don't do it. So it is really very important that this is being prioritized.
That's a very good point. Thank you very much.
Thank you.
Maxime Toulotte, thank you. So you are Markets and New Solutions Director at French cable manufacturer Nexans. And we heard from Antoine just a few minutes ago that the amount of cables needed in the future is literally going to be galactic. What does that mean for a cable manufacturer like you?
So for us it means, so first of all, thank you for having me today.
Can you hold the microphone a bit closer?
Yes. For us, it means, first of all, technology development. So we have now developed HVDC cables that allow to, basically with one cable, you can transport much more power than we used to do before. So it's at least one way of doing it is to be able to transport more power. So we need, in fact, per megawatt or gigawatt transported less cables. So the first aspect is the technology development, and the second aspect is what we see on the picture, is increasing our manufacturing capabilities. So this is a picture of our factory in Halden in Norway, and on the front side we see the second tower that we have built recently and that we have inaugurated actually 2 weeks ago. And with that, basically we doubled the manufacturing capacity of this factory. But it doesn't come alone, obviously. When it's good to have cable, but then you need to install them. So if you go to the next slide, you have a picture then of our cable laying vessel in our second factory, which was also a recent investment, in order to be able to install. So you need to have the cable laying vessel to come to the factory in order to pick up the power cables, and after all to go in the site to install. And so all that goes hand in hand. So you increase your manufacturing capacity, but you also need to add additional installation capacity in order to be able to install this cable, and that's what we have done now over the last 5 years.
And you also, obviously, you have technical developments such as for floating wind energy. I understand you're cooperating with a few grid operators such as RTE on some innovative projects, right?
Yes. So we are lucky in Europe. We have a very strong transmission system operator. There is RTE, there is TenneT. And with them, we can cooperate to develop technology. So typically, we developed HVDC 525 kV some years ago for TenneT, and now we have signed contracts in order to connect the future offshore wind farm to the shore. And then the next, in a way, the next frontier is to go to floating wind and then to develop high voltage cable and high voltage HVDC dynamic cables for the future big floating wind farm that will be built in France, but also abroad.
Yeah, as you said, you're also exporting these technologies. To what extent do the markets differ from each other, or is it pretty much the same in the UK, in France, technically?
So, depending the market, we have either our clients are the transmission system operators. In some other markets, it's the developer. But then it depends. So at least, for instance, in France, RT is then able typically to, or TenneT in Germany, they're able to group several offshore wind farms and then to have, for instance, HVDC that is connected to shore. So that's quite something that is interesting, because then in that way you mutualize different offshore wind farms. Eventually you have hybrid interconnectors to connect directly to an interconnector. So it differs. In other countries, like in the US, there is then the developers that is working on the connection. And that's, for instance, where we could also export typically floating on the West Coast in California, which has very deep waters, and where we should be able to install dynamic cable there.
We heard from Antoine just earlier that there will be some scarcity of certain materials like copper. You've come up with a way to deal with that, I understand.
Yes, so in Nexans, we decided some years ago to keep our casting lines. So we are basically vertically integrated. We are able to make our own copper wires from cathodes. And this is basically something you can use in order to integrate recycled copper, typically. So based on the pitch before, so indeed there is a huge number of cables that have been installed in the past that will most likely need to be decommissioned, removed from the soil, and we have basically a lot of mine under our feet that will be decommissioned, and that we are now looking to see, in order to maximize the content of this old cable that we can then strip down, recycled, and as well reintegrate in our casting lines.
All right. Thank you very much, Maxime Toulotte. Thank you, Jeppe Johansen. And thank you for listening.